I have here a polynomial function, and we're told to graph it. So let's go about doing this in the way I go over in class. I prefer talking about the x-intercepts first. And the place these come from is these factors right here. Okay, I'm going to look inside each parentheses and talk about what's inside the parentheses. I don't care at the moment about that squared, although that's important. I don't care about this -4/5, although that's important. For the x-intercepts, I only care about what's inside the parentheses. So let's go about doing this. And we're going to start with x plus 1. What I'm going to do is I'm going to say, set that equal to 0. Okay, because if that equals 0, think about what happens. I've got -4/5 times 0 times something. The result will be 0. In other words, the y value will be 0, meaning somewhere along this curve, I'm going to have a y value of 0. That's an x-intercept. So that's why this works. Whoa. I'll be a little more careful with my eraser. There we go. So we're going to set x plus 1 equals 0, and that means x equals -1, which produces this coordinate point, -1, 0. I'm going to do the same thing with this other guy over here. I'm going to say x minus 5 equals 0. Well, that means x equals 5. And that means I have another x-intercept at 5, 0. So you'll have as many x-intercepts as you have factors. If you have 3 factors, you'll have 3 x-intercepts, and so on. Now, let's talk about the y-intercepts. So let me clear some room. Let's talk about this guy. And the y-intercept is pretty easy if you're given the unfactored form, the standard form. You can find it in the factored form over here. But what you want to do is basically set x equal to 0. That'll give you the y-intercept. Well, in unfactored form, standard form, this is quite easy. All these things over here go to 0, right? I just cover them up. What's left? Well, it's just 4. So that's 0, 4. I like standard form a lot because it tells us what the y-intercept is. It's super obvious. But if you don't have standard form, I'm not telling you to multiply those factors out. That could take a while. Instead, just plug x equals 0 into each of those factors and just evaluate the function. Okay, so you have your choice, but the y-intercept should not be too hard. Now let's talk about the end behavior. And this is a topic we approach a lot in class. What is really going on with this thing? Right here, this power function. What kind of a power function is that? In other words, remember I have 4 categories. I have negative even, negative odd, positive even, positive odd. Well, if you take a look at this guy, let me get some space again. See this negative sign right here is going to dictate the behavior, the end behavior, and this asymptote, this exponent is going to dictate the behavior. That's odd. So I have here a negative odd end behavior. And we'll just put that down right here, negative odd. Okay. Now I'm ready to graph the function, and I'm going to use black for my intercept points. I'm going to put one here, -1, 0, and the other one's way out here, like 5, 0. Right? I also have a y-intercept at 0, 4, something like that. So what is the function doing? How do we connect these dots? I think some of them are going to be obvious. Like, it has to look like this. I can't go down and then back up. Do you guys see why? I just made an x-intercept. That's not allowed. You can't just make x-intercepts when you're drawing a graph. You have to use, you have to use only the x-intercepts that are shown to you. So that means we're going to go like this. And now the question is, what else does it do? Does it bounce or does it cross? So let's look at each one of these intercepts in turn. If you look at this x-intercept, see that 2 right there? That means that is a bounce. Okay? So when I get to -1, I go doink off of it. Okay? Like this. I go shooting up to the left. But this one over here at x equals 5, that has a single exponent, like a 1. That's an odd number. That means we cross. So we go down like that. And then you ask yourself, is the end behavior right? Okay, is this negative odd end behavior? Well, if you remember what negative odd looks like, that's a shape like this. Okay? It's odd because it's not symmetric. It's going kind of wonky up and down. And then it's negative because it is actually heading in a down direction. Okay, so this all checks out. Everything's matching.